Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Guys, today we will see the important question answers related to the engineering geology course which are most likely to be asked in the exams with reference to the rock and its characteristics. We are studying the concepts related to the engineering geology based on some rock mechanics and the soil mechanics concepts. Here, the concepts or the terms which are asked with reference to the exam point of view are based on the rock minerals, slope stability, foundation analysis, tunnels and excavation purposes or the infrastructural development point of view. Here, the first question related to the engineering geology, which is most likely to be a application oriented question, where the concept based on some ge- geological parameters like axial plane and limb. Here, a site is proposed for excavation of a tunnel along AB and MN, passing through axial and limb region of fold respectively. Justify the suitability of tunnel in such condition. So we have to justify our answer with reference to that condition. Is it the AB or MN like passage is feasible to construct a tunnel or not? So your answer will start with reference to the diagram. That diagram is not available in the question paper. You just get the question and the total marks are 5. Draw the answer or the diagram based on that question which are related to the fold which is anticline which is required for tunnel alignment. In that syncline part we can't construct the tunnel with reference to the geological textures available. Here the AB and MN, these are the two locations. See, AB location is there and MN location is there. So tunnel AB which is the axial region and tunnel MN which is the limb region. Likewise, here the crest part is the uppermost part where these are the two limbs which are from crest to the downward direction. With reference to the rocks available beneath to that syncline or anticline part, this upper portion is the anticline part. If we go the downward side, then it will be a syncline part. Likewise, we are constructing the tunnel in the upward region as we have to connect the two road surfaces from this way and this way. Here the sandstone, shale, limestone and siltstone, these are type of rock layers are available with reference to the anticline where we have to plan our tunnel alignment. So your answer must have to justify the AB, that is tunnel along AB which is the axial region, and tunnel along MN limb region which likewise. So here we have to justify that is suitability of AB or MN. So here the MN limb region is suitable because it passes through the limb where rocks are comparatively undisturbed and competent. Means hard rock or hard strata is available with reference to MN because it is deeper inside. Joints are fewer, more persistent and but less closely spaced. So there will not be any cracky nature or less cracks available. Groundwater condition is generally favorable so that the excavation will be easier with good exposure and stability. On the other hand, if we go through the AB alignment that passes through the axial plane where rocks are highly deformed and fractured, so the stability is not as much as required. So joints and cleavages are numerous and closely spaced where high possibility of groundwater seepage along the fracture and axial plane is occurred. Due to that, we can't go through that AB region. So our answer will be suitability point of view. MN region is suitable. So the key geological facts which are most important to write in your answer that fold consists of limbs and axial zone. Axial region is structurally more disturbed where limbs are comparatively stable and competent. So tunnels behavior better in competent, massive and less fractured rock. So for that purpose of construction, we have to follow some flowchart where we have to first identify the tunnel alignment, which is the criteria of suitability. After that, we have to evaluate that geological conditions by using geological subsurface exploration, where deformation, jointing, rock strength, groundwater availability, etc. points are studied and noted. After that, we have to check the assess stability and support requirement, which is external support required, or the stability which is available beneath to that earth surface with reference to the sandstone, shale, likewise rock. After that, we have to check the suitability and non-suitability on the basis of adequate and responsible support. So if large amount of support is required, then it is not suitable, but if the rock itself is stable, then it is more suitable. Likewise, we conclude our answer, that is tunnel passing through the axial region of faults are generally not suitable due to intense fracturing, deformation and seepage, whereas the tunnels through limb region are more suitable due to better rock quality, fewer discontinuities, lesser seepage and higher stability. So good geology where we have to construct the safe tunneling. Likewise, if we have to compare these two AB and MN point of view region, that is axial region and limb region, with reference to the tunnel alignment, then there are so many aspect ratio, or we can say that the characteristics on behalf of that characteristics we can cross check our tunnel alignment, or we have to compare our tunnel alignment. Here the tunnel AB axial region, this is the second column which is not suitable, where tunnel MN which is the limb region which is suitable. So that suitability which is on the basis of support requirement, stability during excavation, groundwater condition, joint discontinuities, rock strength and geological conditions. So here the question is asked for 5 marks. So the bifurcation of that 5 marks is likewise that neat level sketch diagram 1 mark, explanation of geological condition in axial region and explanation of geological condition in limb region, one and a half marks for both. Then comparison or justification of suitability 1 mark. So you can additionally mark that flowchart also for your answer purpose. So this is the actual answer required for that whole question for 5 marks. Next question related to that engineering geology, where write a short notes on parts of fold and strike and dip of rocks. Okay, so this question is off for 5 marks. Here the concept related to the geological basically structural geological component like fold and strike and dip point of view. So two parts are there, we have to write a short note on the parts of fold, and second part is the strike and dip of rocks. So first of all we have to see the marking scheme for 5 marks, where part of fold 2.5 marks, strike and dip of rocks 2.5 marks. So this bifurcation is along wise. Likewise, here we have to draw the diagram which is most important, because if we have to show the fold, then we have to draw the diagram with reference to it. What is meant by fold? A fold is a bend or a wave like deformation in rock layers due to compressional forces without rupture. So what are the components of that fold? They are listed below. 8 components are there: syncline, anticline, axial trace, axial plane, trough, crest, hinge and limb. These are all most important parts of folds. So these parts of folds based on some position and axial point of view, that is symmetry and not symmetry, where upright symmetrical, inclined asymmetrical, oval turn, recumbent and isoclinal. Likewise, that types of folds are explained. So axial plane is vertical and limbs are equal in upright symmetrical. Axial plane inclined and limbs are unequal, that is inclined asymmetrical, where both limbs incline in same direction, that is oval turn. Axial plane almost horizontal, that is a recumbent, and the isoclinal will be the limbs are parallel, thickness nearby same, that is a symmetrically also, that just like the circle point of view. So the parts of folds are explained with reference to diagram with the axial plane. These are all the components of that fold. On the other hand, we have the second part, that is streak and dip of rocks. So rocks occur in the bed planes, that are the strike and dip of rocks. We can study the attitude or orientation of a bed is described by its strike and dip. Means if we have to study the actual orientation of the rock surface which are available beneath to the earth, then we have to go to study the strike and dip, its orientation, its angle of dip or its incline part. Likewise, so here the first diagram of strike is there and second diagram of dip is there. Here the strike is the horizontal line on the bed surface in any direction. it is given by the line of intersection of the bed with a horizontal plane. That strike is always perpendicular to the dip direction. Most important line. Strike is always perpendicular to the dip direction. Means that dip here. So what is meant by dip? Dip is the maximum angle of inclination of the bed with the horizontal plane. Dip is measured in vertical plane at right angles, that is perpendicular to the strike. It always measured in the dip direction, where dip varies from 0 degree horizontal to 90 degree vertical. So this is most important answer for that part, strike and dip of rocks. Where the methods to determine the strike and dip, that is the field method, which is most important, use with reference to the procedure or step-by-step procedure from the selection of the fresh exposure of the bedded rock, then place of the compass of clinometer of the rock surface, turn the instrument. Likewise, we get the till the clinometer down to the dip and basically we have to measure the dip angle and the strike line. So what is the note? Strike is recorded as the azimuth of the strike line. For example, north 30 degree east, where dip is recorded at the angle and direction where 30 degree towards southeast. This is the most important comparison for strike and dip point of view. So what is the most important benefit of these two parts, that is parts of fold or strike and dip of rocks with reference to the civil engineering point of view? The importance is for controlling the groundwater movement in tunnels and excavation point of view, we have to study. Then influence of stability or instability of slopes and foundations with reference to the hilly region, roadways or railways. Then which is affecting design and orientation of dams, roads, canals or nearby valley portions. And which is most important, helpful in prediction of rock behavior and failure planes. Okay, so notice that understanding faults and the attitude of rocks is essential for safe and economical planning, design and construction of engineering structures. Stay tuned guys. Happy learning.